Now we'll move to one of our favorite things to eat, which is fat. Now, fats contribute greatly to the flavor and texture of our foods, and we describe these fats as lipids as a generic term. It includes triglycerides, which we're going to spend most of the time talking about, phospholipids, which are a minor contributor from our diet, and sterols, such as cholesterol. These are 9 calories per gram, which makes them much more caloric than your carbohydrates and, as we'll see, proteins. These are long carbon chains, much longer typically than your proteins and your carbohydrates, and these do not readily dissolve in water. So we'll take a look at our structure here. Notice the chains of carbon surrounded by hydrogens. Now, saturation means that all of these carbon binding sites are covered with hydrogens. It's saturated with hydrogen. If there is a double bond between the carbons, that means that the molecule isn't saturated, so we call it unsaturated. And if there are multiple double bonds, as you can see in the third and fourth molecule here, it is polyunsaturated. And the name of these polyunsaturated fatty acids is based on where the first double bond is. If it's at the third carbon, it's called an omega-3 polyunsaturated fatty acid. And if it's at the sixth carbon, it's called an omega-6 polyunsaturated fatty acid. Now, the number of carbons is almost always an even number. And this is because of how these are constructed and broken down. It's always in 2 carbon segments. The length of the carbon chain tends to correspond with its physical properties. Short chain fatty acids, which are 2 to 4 carbons in length, are more liquid, while long chain fatty acids, 12 or more carbons in length, tend to be more solid at room temperature. Now you can see some of the sources. Our saturated fats tend to come from animal products, with the exception of some tropical oils like coconut oil and palm oil especially. You can see in 100 grams of cheddar cheese, a cup of shredded cheddar cheese, you'll get about 21 grams of saturated fat. And monounsaturated sources, which tend to be more plant-based, olive oil, avocados, some very popular ones, you'll get about 12 grams of unsaturated fat from typical size avocado, and you'll also get some saturated fat in there as well. Understand that most fat sources have a bit of all of these, and overall we just tend to think of what they have the most of as a percentage. As we look at the polyunsaturated ones, we have fish oil and salmon, which is very high in these omega-3s, and then we have flaxseed as well. We'll talk about the omega-3s and omega-6s as we move forward. Let's first take a look at trans fats. Now, when a double bond is created between 2 carbons, it's typically in what we call a cis formation. This means that the hydrogens are connected to the double bonded carbons on the same side. And this creates a kink in the molecule, which gives it its physical characteristics, like being liquid at room temperature. This is common in unsaturated, usually plant-based fats. The problem is for cooking and baking purposes, they aren't as ideal as saturated fats. And in the 70s, when saturated fats began to be demonized for increasing LDL cholesterol levels, which increases heart disease risk, food scientists came to the rescue and they created a new fat from plants that acted like saturated fats. And what they did is they simply moved a hydrogen from the cis configuration to the other side of the carbon, making it a trans configuration. And this straightened out the triglyceride, giving it a functionality like a saturated fat. And this occurs in nature, in some cases, in a cow's rumen, where it can actually have health benefits. And these industrialized trans fats ended up increasing LDLs and decreasing HDLs. That's the wrong direction for both of them, and it leads to rapid rates of heart disease. It's since been almost eliminated off of our shelves. However, if you read the words partially hydrogenated on an ingredients list, that's trans fat, so you'll want to not purchase that item. If there are less than half a gram of trans fats per serving, the product is considered free of trans fats. It can have a 0 in the grams column, so don't just look for the 0 in the grams column, look for partially hydrogenated. Now, omega-3s work to promote heart health and reduce inflammation. They're very anti-inflammatory. After being consumed, EPA and DHA become part of the membrane of our cells, where they can affect proteins regulating heart rhythm. They can be converted to potent anti-inflammatory agents called resolvins and protectins appropriately. In addition, they can bind in the cell nucleus to affect the expression of particular genes. This tends to be very positive. There appears to be an antidepressant effect from omega-3s as well. Doctors have prescribed these fats for major depression, postnatal depression, bipolar disorders, schizophrenia. We have 3 different types of omega-3s. We have the fish-based types, which are DHA and EPA, and then we have the land-based type, which is ALA, which is alpha-linolenic acid. This is the primary type. It actually has to be converted into EPA and DHA in the body, and it only does so at about a 10% clip. Just 4 ounces of Atlantic salmon provides more than 1 gram of these omega-3s, these fish-based omega-3s obviously. And on the chart here we can see the adequate intakes and what the recommendations are for omega-3s across the lifespan. Overall, 250 milligrams a day or 2 grams a week of EPA and DHA can reduce the risk for cardiovascular disease, but we just don't simply get this amount. A major concern with fish consumption are heavy metals like mercury. Also, overfishing has become a problem, so organizations such as the Monterey Bay Aquarium, and the USDA has a similar one of these in your book, they come up with a chart with the best choices for fish with your health and the environment in mind. So where did the fish actually get the omega-3s from in the first place? Well, it comes from the algae that they eat. And in general, the fish with high omega-3s are large carnivorous fish who eat smaller fish, who eat smaller fish, who eat the algae. And the omega-3s accumulate and you've got a healthy dish. However, the mercury can also accumulate, and this has led companies to turn to algae-based omega-3 supplements or krill oil omega-3s to avoid the threat of the mercury. And you can learn more at the NIH. They have some really nice summaries of individual nutrients, and I recommend using it as a resource in the future for you. And here you can see how these omega-3s are divided up. Your number 1 omega-3 source is flaxseed, and even though it has ALA, which has to be converted, like we said, to DHA and EPA, there's just so much of it. But make sure that when you consume flax seeds, be sure not to eat them whole. They have a very tough fibrous shells, which we can't break down. We'll call those beta bonds, and they'll just pass through you. Buy the ground flaxseed or grind them in a coffee grinder prior to adding them to a smoothie, oatmeal, or a dish. But they're a great addition to your daily diet. Let's move on to omega-6s. These are another type of essential fatty acid. Now, essential means that we need to eat them because we can't make them ourselves. These are critical for our normal growth and development, and they tend to promote more inflammatory processes in the body, which is very necessary if we have, say, a wound. In fact, the primary omega-6 fat, linolenic acid, is converted to arachidonic acid, which is a trigger for inflammatory processes in response to tissue damage. Advil and other NSAIDs, as well as glucocorticoids like hydrocortisone shots, they inhibit this arachidonic pathway to be anti-inflammatory. If you take a pharmacology course, you'll become intimately familiar with this. The problem is that we have way too many omega-6s in our diet than we should relative to the amount of omega-3s, and it throws off the necessary balance of inflammation and anti-inflammation. While we should have a ratio of something like 2-to-1 or 4-to-1 omega-6 to omega-3, our ratio in America is in the range of 14-to-1 or 25 to 1, omega-6 to 3. And this is due to processed foods in our diet and the low omega-3 intake that we have. Recall that chronic illness, they tend to all be inflammatory conditions, and you can see how our diet can play a role in our long-term health. And not all omega-6s are inflammatory, though. Gamma-linolenic acid is thought to reduce inflammation if we have enough magnesium, zinc, vitamin C, B3, and B6 present. But omega-6s appear to enhance the growth of prostate tumor cells. So if you or somebody that you know is at risk for prostate cancer, this is one that you definitely want to stay away from. Now, these are a chart of dietary fats, and I want you to notice that each one of these oils are a combination of all kinds of these fatty acids. It's always a mixture, but we also have to consider how they're being used. There are other oils much healthier and safer than canola oil up at the top there. Olive and peanut oils are two examples of ones that are safer because the fats in canola oil that have been heated to, say, 300 degrees Fahrenheit or above, they can produce free radicals. Free radicals can damage cells as well as DNA, and if you use canola oil, combine it with spices like dill or bay leaves or garlic or onions or black pepper to reduce that free radical production. All right, so in recent news, cholesterol is no longer considered a nutrient of concern. That limiting cholesterol isn't necessary anymore. There have been many conflicting studies regarding the influence dietary cholesterol has on blood cholesterol levels. The chair of cardiovascular medicine at the Cleveland Clinic says that the move was the right decision, and they got the dietary guidelines wrong. So cholesterol is necessary for proper function. It is used to make steroid hormones like estrogen, testosterone, and cortisol. It helps make vitamin D, and it's an integral part of our cell membranes. The issue is the amount of cholesterol floating in our bloodstream in lipoproteins, such as those low-density lipoproteins, LDL. The more of these that we have, the greater our risk for heart disease, as these directly contribute to the process of atherosclerosis. The influence on the blood cholesterol level tends to be the mix of fats and carbohydrates in your diet, especially sugar and saturated fat. We'll see if recommendations for special populations such as diabetics will keep the recommendations to limit cholesterol, but for the general population, we are free to consume it. Now, there's an interesting phenomenon in physiological research. Not everyone responds the same way to a stimulus. Overall, a study may show a weak relationship between the amount of cholesterol a person consumes and their blood cholesterol levels. However, for some individual people, it does have a strong relationship. And these people are considered responders, and these people should be avoiding cholesterol-rich foods. And right now, the only way to find out whether you are a responder is trial and error. I have a friend who is a responder, and he knows that if he has high LDLs at a checkup, he can just correct it by cutting eggs from his diet. Most of us, however, are non-responders, and because of it, the recommendations have been changed. So here's a look at the cholesterol transport pathway. The pink pathway is called forward cholesterol transport, and this is where the liver sends out cholesterol and triglycerides in very low density lipoproteins, the VLDL. And as it gives away its triglycerides to the cells that need it, it becomes an LDL, which deposits necessary cholesterol to the cells, and in high amounts, it can deposit cholesterol in the wrong places to promote heart disease. HDLs, on the green side, these are sent from the liver to clean up any excess cholesterol from the cells. And having more of these is protective, so be sure to exercise and raise your HDL levels. So let's move back to saturated fat. And differences lie in the fates of saturated fats and unsaturated fatty acids. And while monounsaturated fatty acids are more likely to be safely stored in adipose tissue or burned, saturated fats are more likely to be toxic. We know that palmitate, a 16-carbon saturated fatty acid from meat, dairy, and eggs, it causes insulin resistance. Also, saturated fats can result in toxic breakdown products accumulating in various organ tissues, which can lead to dysfunction of the mitochondria and further insulin sensitivity issues. Now, interestingly, if those insulin-producing beta cells that we talked about in a previous lecture in the pancreas are exposed to saturated fat in a petri dish, they begin to die. You don't see the same result in monounsaturated fats, and this means that insulin secretion may be impaired with saturated fats as well as downstream sensitivity at the liver and the muscle. Now, lots of research is being conducted in adipocyte biology to gain a further understanding of the interactions between hormones and inflammatory markers and patterns of fat storage and oxidation at different tissue sites. We know that fat is not only stored in adipocytes and muscles as energy reservoirs. When inflamed, as we talked about on the last slide, it can be stored what we call ectopically or misplaced in tissues like the liver, causing non-alcoholic fatty liver disease or steatohepatitis. It could occur in the muscle, causing muscle insulin resistance, or this ectopic fat could be stored in the pancreas, where it can inhibit insulin production. It could also be stored in the heart, where it can be a major contributor to cardiovascular disease. So it appears that our bodies rely on fluctuations in energy levels that are continuously fed condition without energy depletion from exercising or fasting can lead to the serious long-term conditions that we associate with obesity and metabolic syndrome. The American Heart Association recommends keeping saturated fat levels low, and that is below 5 to 6% of calories in your daily diet. Current intake is around 11%, and this is typically coming from cheese, pizza, grain-based desserts, chicken, sausage, hot dogs, bacon, and ribs. Sounds like 4th of July. So what does this actually mean? So for a 2,000 calorie a day diet, this would equate to about 13 grams of saturated fat per day, at maximum 13 grams. Now, what if you had 0 grams? Would that be a bad thing? Absolutely not. Vegans get by just fine without their saturated fat, although they get some from some plant-based sources. But that is not a necessary source. In fact, we create saturated fat ourselves when we consume lots of sugar. As we saw in some of the Lustig videos, the fructose in the sugar ends up being converted to saturated fat in the liver. So a high sugar diet is a high saturated fat diet, and that's something to take into consideration when looking at these recommendations. You could be consuming very few saturated fats individually, but on a low fat, high sugar diet, you could be creating just as many saturated fats. And as we look at our lipid recommendations as a whole, the dietary guidelines for Americans say that our total fat intake should be about 20 to 35% of our total calories. You don't want to go below 20%, although some diets out there will suggest that you should. You have to have medical clearance in order to consume less than 20%, or at least to tell somebody that they should consume less than 20% of their calories from fat. And this equates to about 44 to 78 grams per day, put it in perspective for a person consuming that 2,000 calories per day. Nationally, we are taking in about 34% of our calories, which is within the range. However, we are consuming more total calories than we should be, which raises the total absolute grams of fat that we're taking in. And that's it for lipids. For more information, be sure to read your Chapter 5 in the textbook. It is a required reading. This is simply an overview and some added tidbits along the way.